Hi, my name's Beth. I'm going to talk a little bit about how my company Learnerbly has used Elasticsearch in our searches, and some of the problems we came across and why we decided to use Elasticsearch. A little bit about me. I have a computer science background from university. I actually took 2 years teaching with Teach First. So when I joined Learnerbly, it was kind of my first role, and I'm a full stack developer. I've been there for 2.5 years now, and quite enjoy it. So what Learnerbly does is it's a workplace learning platform. It works by a company is able to assign their employees a learning budget that the employee can then have the freedom to choose what to learn rather than being told you have to learn this one resource, so they can get the most impact from their own development. We, as the platform, manage the resources available for users to request, and we also manage things like the budgets of the users, payments. So we've recently integrated Stripe and the Amazon API so that we can have automatic fulfillment. When I started at Learnerbly, I was one of 4 developers, and we've grown since then. We're now 10, 12 next week, and we're still hiring. We're hoping to have another team full of more engineers. So a little bit about Elasticsearch. Oh, sorry, it's not skipping some slides, so it might be a bit buggy. But so my favorite piece of technology I've used since joining Learnerbly has been Elasticsearch. It's kind of almost been like a nerdy bit of an obsession. And what it is a real-time distributed search with analytics. And we used it for its speed, which has helped us scale. Part of using Elasticsearch was to have the ability to have multiple searchable indexes. So like the tables of your traditional database, in Elasticsearch, they're called indexes. So we wanted to have multiple ones that we could search by, so we could simplify and scale our queries, because some of them would maybe normally touch 2 database tables or become really large and complicated. It also allowed us to apply multiple filters, so we didn't just have to filter by one thing. With Elasticsearch, we were able to index the data in the way that we wanted, so it didn't always contain every single part of the related table on Dynamo, and we could also add in other parts from other tables based on how we wanted to search our data. It also has capabilities on the more fuzzy search side, so dealing with things like typos and misspellings, and also for relevance in search result. So in our example, if we said that a keyword in the title is more relevant than it being in the description, we can rank that higher up in the list for relevance. We use Elasticsearch with the OpenSearch service on Amazon Web Services and use Kibana during development. We also now have our infrastructure with Terraform, but I'll get onto that a little bit later as well. So on the screen is a little screenshot of the product. This page would be visible to the admins of a company that uses the product. So an admin would be able to see all of the users and their budgets and being able to filter them and search for users as well. I'm going to focus kind of on a case study that we did when we were trying to implement some of the searches with Elasticsearch. Part of scaling as a startup is we gathered more clients with more users, and we had to add features such as CSV upload and bulk actions to then manage those users. There became a need for the admins to have better management of the budgets of the users in their company. So these admins were requesting to be able to filter users. For example, if they wanted to give a top up to all the users in the engineering group, or wanted to find all the users that didn't have an approver so that they could apply one. We needed to have a scalable solution to apply multiple filters, and we also needed to be able to handle the increasing load. Just a small glimpse of how the queries look on Kibana. So on the left is the type of query we use. On Kibana, the data isn't dynamic, so it's hard coded that I've put in geographic location to get this response back. And on the right is the response that Elasticsearch would give. So even a complex query like this, where you're applying multiple filters, would only take like milliseconds, which is part of why Elasticsearch was great for us. So one of the great things about using, One of the great things about using Elasticsearch was how easy it was to make a query. We could use our code to make the query dynamic based on what data was sent in the GraphQL query. So if more than one group was selected, or the admin wanted to search by multiple countries, so anyone that's in England and in Spain, then we would only apply those filters to the query and not any ones that are irrelevant to that person's query. So rather than originally post-filtering in code, we were able to directly apply all the filters in the Elasticsearch query, which was then quicker than querying more than one database and then mapping over that data when it was received. We were also able to apply some filters after initial ones. So first we could filter by all the users in the target organization and filter out those that are archived, and then add these filters afterwards. On the more analytic side of Elasticsearch, meant that we could add something that was called an aggregation to get all of the different countries of the users within the organization, which we then used for the filter selection options, as we don't actually have a centralized store of all the countries that employees can be in, because this came as we grew and went to and rolled out in different countries, and then we've had to deal with this after. So some of the problems we faced, I've included a little diagram here of some of the products we use on AWS and how our data is written. Because what is stored in Elasticsearch is independent from our original data store, so it's independent from our DynamoDB tables. When the data is updated, the Elasticsearch index also needs to be updated with the newest data. And we're finding with Elasticsearch, you can't always have an exact source of truth for the data. The way we manage user budgets isn't directly linked to the user. So we could end up with a case where a user has only just spent the last of their budget, and Elasticsearch indexes still need to update, and we're showing them as not having budget. So we're trying to find ways that we can index the data in the right places, and we're doing it when the user is updated. Initially, we only served in the United Kingdom, as I mentioned earlier. And when we went global, we needed to make the platform relevant, so showing relevant in-person courses. We needed to introduce then a new field on our database and onto Elasticsearch for where our users lived. So we needed to add a new key and value to all the previous documents, which I think was about 37,000, and we needed to update them with this data. And the way we did this is we just ran a script over all of those users, which was interesting to see how our DynamoDB streams responded to this. But it was probably one of the benefits of being a startup at this stage, was that we could do this, which with Elasticsearch could be an issue as we do scale. So it was good that we found this out now, and we might have to think a little bit more about how we plan our indexes. Another issue we came across is to do with our infrastructure. So I've just included a little snippet of the mappings for Elasticsearch. So these are kind of like a schema for your database. One of the first times we used Elasticsearch as a team, so this is a different example to the one I've given, was really early on, and we were just a team of 4. So there wasn't the broadest Elasticsearch knowledge, and I had been there for only a few months, so I was having to learn everything completely from scratch. One of the shortfallings with Elasticsearch is these mappings you can't just change. To change your mapping, you need to completely trash it and then re-index everything to apply that mapping. So with development, it was getting a little bit clunky, having silly names like archived 1 and archived 2. We would also apply all of our mappings in the Kibana UI. So there's commands that you can put in that will put in your mappings. And we also did this for our production data, which made it quite hard to keep track of our mappings and all of the infrastructure, which we put into a README file. It was often forgotten to then go back and update this file and keep it completely accurate. So one way we've mitigated this issue is we now have an infrastructure as code approach and use Terraform for this. We do still break the indexes when writing data to Elasticsearch, like with the example here with the types. If you're accidentally writing a date when you should be writing a Boolean, sometimes we are breaking them. We've got a little bit more safety with this as we are refactoring our code base to TypeScript, which then shows us, it kind of gives a sanity check whether we're on the right track. So on that, because of the flexibility that Elasticsearch gave us, we were able to pass in different filters to be queried, and they all varied with the type of data. So it could be arrays or Booleans, say, for the example of geographic locations, it could be an array of different locations, but if you're searching if a user has a budget, it's going to be a Boolean. So then typing these in TypeScript did become a little bit of an issue. And we ended up going for a union type for any of the 7 available filters. Because we try to reuse our backend queries, we need to make sure that this filtering work isn't breaking any of the other queries. And we have added integration tests to this. So it's really unfortunate that the integration talk is happening at the same time as this one, because we should be in it. But yeah, so we're adding more tests. So hopefully we can fix some of those issues. So a couple of recommended resources. So with Learnerbly, we also get as employees, our own budget. And these are 2 books that I've bought with my budget. The definitive guide, I really, really recommend for getting started. I'm quite old school and like having a book in front of me, and I definitely used it a lot to get myself off the ground running when it came to first implementing Elasticsearch. I'd also recommend the Relevant Search book for like the next stage when you're trying to improve the search results. It has a lot of information on why something might rank higher, and I'm reading through it at the moment, which is quite interesting. So in summary, one of the benefits that Elasticsearch gave us was our queries were becoming really, really complicated when we wanted to add multiple filters. And using Elasticsearch allowed us to really quickly get our data back and write it in a really easy, dynamic way that we could understand in future.